Welcome everyone and welcome to the next lesson of the School of Solana. And in this lesson we are going to talk about the security best practices. This is already lesson number 7 and in this lesson we are going to talk about the security for your smart contracts. We at the Eki Blockchain Security, you most likely already know that we are security researchers, security auditors. We have a lot of audits performed in the past few years. And we are also developers and creators of the security tooling. So for example, from the Solana ecosystem, it is Trident, the first fuzzing framework for the Solana programs. Then we have also the VS Code extension, which is more for the developers. I mean, integrated into the cursor or VS Code. You can use it for the real-time analysis. And for example, from the Ethereum perspective, we are also creators of the Wake framework, and there are a bunch of additional tools that we are currently working on. So that's why we also want to teach the security. For this purpose, last year we had run security bootcamp, which was dedicated mainly for the security of the smart contracts. The reason why I'm talking about it is because there are a lot of resources about the security on the Solana, so I think it is more appropriate for you to check it out. And also there was a CTF, so if you want to break the code, if you are more skilled developer or security researcher, check the CTF out. We will leave the link in the description, and you may break it. Apart from the CTF, as I said, there are security materials, so we think there is plenty of stuff related to the security. So that's why we are actually using one of the lessons that was presented in the bootcamp, and it is about the security pillars. So you will learn what are all of the security pillars from the security perspective, from the perspective of us auditors. You will learn what you can focus on. You will learn how to test, how to fuzz the smart contracts, what steps you should do before going for the audit, etc., etc. So I think this is everything from the introduction. I hope that you are enjoying the School of Solana. We hope that you have learned a lot of new stuff. And we can go directly to the lesson, so enjoy. In this lesson, I would like to talk about the security pillars that I think, based on the experience and the knowledge, are important during the writing the smart contracts or bigger Web3 applications. So what are actually the pillars? What is the iceberg? What is the pyramid of the security? So it starts with the code quality. You have to keep in mind that the hacks are created by the developers. So you, as a developer, you want to create new protocol, new application, you have great idea in mind, but you are the developer. You actually create the hacks. So instead of having attitude that you are perfect, and also I'm not perfect, but instead of having this attitude, you have to always keep in mind that these issues, these security issues and the bugs are actually created by people, so by developers. So you have to start from yourself, and you need to learn what are the best practices, or on the other hand, what are the most common security issues. We will talk about this, but you can also have knowledge, or you can check the OWASP 10, let's say, so you can see what are the most common security issues from the year 2021 or 2017. The next part, which is also really important, but I think underestimated, is testing. So Testing is important from multiple points. First point, obviously, is to test your Solana program if it works correctly. Most of the time, developers do not write tests, and they only write the tests for the auditors, so they have the great feedback or the good feedback from the auditor's side that they actually wrote tests. But the purpose of testing is also to think like a hacker and to try to break your application or the smart contract. When you have the great baseline of code quality, you can use testing to test the vulnerable parts of the source code and to be sure that actually you did great job while writing your smart contract and you did not create vulnerabilities. So these all are importances of writing tests, not only to test the correctness of the two inputs that are on the instruction, or for the happiness of auditors, or for the great feedback from auditors. The next part is about the more advanced testing. We think that the fuzzing is really superior to integration tests, but this does not need to be necessarily only about the fuzzing. There are multiple more advanced testing techniques that you can use, and these are, again, you may ask question, why should we use more advanced testing when we already implemented testing in the second part and integration testing in the second part? Most of the time there are scenarios where your smart contracts can be vulnerable to only small space of inputs. Let's say your instructions have 5, 10 instruction inputs, and you cannot test the whole space of possible inputs using the integration tests. You can obviously use techniques such as you generate random numbers within TypeScript, and in the for loop you insert these random numbers to the instructions and you check if the instruction passed or no. But most of the time you are not able to test the whole space of possible values. This is actually why we believe in the fuzzing, because fuzzing lets you test the bigger space than the integration testing. But yet the whole idea is to use more advanced testing that can allow you to test more extensively, to test the small space of instruction inputs, and to be sure that your smart contract works also correct for this small space. The last part is audits. So from my point of view, if you do these 3 previous steps correctly, it is always good practice to have audit, because behind the audit is actually penetration testing team that tries to break your application or smart contract. But if you do these 3 steps correctly, the audit report will contain at maximum low severity issues or warnings, or maybe one medium issue. But audits are also important because you can be biased within your head, and this is the common behavior of people, but you can be biased towards that your smart contract is correct because you used fuzzing or some different advanced technique. So you wrote 200 integration tests, you have experience, so you have great code quality, and you can be biased towards that the smart contract is secure. But from the different perspective, auditors will come and will try to break the smart contract, and from the sudden they will success because you were biased toward the fact that your Solana program is correct or the application is correct. So it is always good practice to have someone else to have a look at the application or the smart contract. And now we can separately talk about each of the pillars. So let's start with the code quality. What can you do? What can you improve here? So the starting steps. Vulnerability risks. Learn what are the best security practices and the most common vulnerability risks. I was talking about the OWASP 10. Most of the time, everyone wants to learn what are the best security practices. But always people forget to also think what are the most common security issues. For this purpose, you can check the OWASP from the year 2021 or 2017. It is basically the database 10 most common security issues. I think it's from that year, that particular year. It is beyond this lesson to go through all of the security issues, but this is your responsibility as a developer to increase the security of your smart contract. You do not need to be professional in each of the security concern or issue, but it is always good practice to, from time to time, check what are the most common security risks for the, let's say, for the last year. OWASP stands for the Open Web Application Security Project, and it is actually widely regarded as a standard awareness document for developers and security professionals. So this is the starting point. You need to always learn and be up to date what are not only the best security practices, but also the most common attack vectors or security issues. When you have the knowledge and the experience, you are up to date, start with the design. Build security into the architecture. In this case, I know you are excited with the new idea for the smart contract or protocol you have in mind, but it is really important to take it slow. Just breathe, take some time, visualize the architecture. That is really important. There are tools such as Obsidian, for example. You can use it for the visualization, for the layout of the protocol. This will actually, when you visualize the protocol, it will help you to spot the issues, let's maybe vulnerabilities or the issues in the architecture from the beginning. And you can work on the issues in the architecture from the beginning, not when you notice in the end that your architecture is actually vulnerable to some attack vectors. Have proactive approach. You always need to keep in mind that you need to prevent rather than react to attacks. I was talking about the OWASP. So learn what are the OWASP 10 common security issues, and if you know what are these possible attack vectors, you can prevent them. When you write your smart contract, you have in mind what are the common security issues, and you can prevent them because you can focus on the security issues. You have in mind the vectors that are possible within different applications to be exploited. Everything from this slide can be actually summarized with the one statement, and that is security starts early. So do not rely on testing, do not rely on fuzzing, do not rely even on audit. Start on your side and learn what are the best security practices, but also what are the most common attack vectors. And these are not that hard to learn. Yeah, there may be some attack vector that requires, let's say, advanced math with the elliptic curves. But on the other hand, most of the time, there are simple attack vectors that are based on, let's say, phishing or weak passwords, for example. And definitely, even without advanced math knowledge, you can prevent these. We can continue to the second part of the code quality. Implement defense in depth. This means implement multiple layers of security. This is always the best practice in the security. Do not rely only on one check. For example, there are multiple constraints that you can use using the Anchor framework within your Solana program. So instead of relying only on one constraint, do not be afraid to use 2 or 3 constraints. And I'm not trying to tell you that the constraints are actually wrote incorrectly, and sometimes they work, sometimes they don't. But you as a developer can create mistakes, and you can think that the one constraint that you used, you used it correctly, but on the other hand, you used it incorrectly, and as I was talking about the bias, you are currently biased towards the security, but actually you created security issue and vulnerability in your smart contract because you used the constraint in this example incorrectly. You can increase the chances, that's the defense in depth. You can increase the chances with multiple layers of the security. So, as I said, except relying only on the one constraint, use multiple constraints. Do not be afraid to double check that the signer actually corresponds to some kind of authority. The second example could be multi-sig. So this is also really great example how to increase the security and how to implement defense in depth. Security through obscurity is, from my point of view, really great term, because most of the time people are relying on the fact that, okay, my source code is private, so what can happen? Or my private keys are stored somewhere in my basement and no one can steal it because they are even locked in the vault. The security through obscurity is really great when we are talking about defense in depth and the layers. So security through obscurity can add another level to this multiple level structure. But do not rely completely on the fact that your, let's say, source code is closed source or the keys are private. Because the source code can be reverse engineered. Some of you may some of you may know this term from the Web 2 security and malware analysis, or maybe even from when you were younger and you were trying to hack some games or insert malicious, or these are not malicious, but steal maybe credentials or codes from applications. So in some senses you were using probably reverse engineering, but what this actually is that from the Web 2 perspective, you can take the application, you can use, let's say, software like IDAPRO is its name. And actually this software can take the binary format of the executable and reverse it to, let's say, assembly or even to some kind of pseudocode. And what are the results or considerations for the Web3 applications, more precisely to the Solana? You know that the executable on-chain is in Solana bytecode format. So this is actually bytecode executable stored on the Solana blockchain in the account. What if your smart contract is closed source and you think you have security through obscurity because hackers cannot see your source code? But the binary format is public on the public blockchain. And if the hacker has a tool that can revert or reverse engineer this binary format into assembly, or let's say into kind of pseudocode, because that is again next step into reversing the binary, then even though your smart contract is closed source, they can completely, or not completely, but they can have at least information about the interface your smart contract uses. That means they can know what are the accounts you expect in the smart contract, what are the inputs you expect in the smart contract in particular instructions, and what are the actually checks you perform in the smart contract. So even though at the end, even though the source code is closed sourced, hackers can revert the binary or we can say reverse engineer the binary, and they can check what are the, or investigate what are the issues, and they can hack your Solana program. So once the hacker knows the logic of your closed source Solana program, the security through obscurity is actually broken. So do not rely only on these facts, such as the private keys are stored somewhere, because you can leak the private keys, or you can click on the phishing link, for example, phishing email. Same goes for the closed source smart contracts. There are always available options how to hack the application. The next point is about the least privileges. Unnecessary privileges always equals potential security breaches. In this case, I have specified role-based access control, and I have also sentence here, common pen testing focus in big companies. So currently, the pen testers that try to break into the big companies and test the security of big companies, this is one of the attack vectors, employees. So I think the term is social engineering. So they leave free USBs somewhere in the park or in the office or somewhere in the reception maybe. They can send you phishing emails. And even though your smart contract or the application can be secure, you can be hacked because of the unnecessary privileges of your employees. So always keep the privileges as low as possible. In this case, remember, the system is as secure is the weakest part. This means the system is secure, but the weakest part are the employees. I was talking about the RBAC, role-based access control. So again, defense in depth, multiple layers of access control based on the roles. So different roles have different access control. For the Solana particularly, we can also say keep account mutable only if really necessary. So if you do not need to modify the account contents, do not use mutable accounts or do not specify mutable accounts. And yeah, the focus on employees is really big portion in the penetration testing. There are questions. How can they react to the phishing emails? Will they insert unknown USB-Cs or sorry, not USB-Cs, USBs to their laptops. So, and these are the weakest points. And this is again, from my side, cliche, but always think like an attacker. I know you may try to, or you are probably biased towards the security that you wrote the smart contract correctly, but again, try to keep in mind that maybe your smart contract is not as secure as you think, and try to think like an attacker. Your source code is closed source, but the binary on-chain is not. I was talking about this in the security through obscurity. So you think that you are protected through the obscurity, but the attackers have actually access to the binary. During the process of writing the smart contracts or the applications, always ask a lot of questions. Is the smart contract really secure? Are all of these functions used within the smart contract secure? Are the dependencies secure? This is really important because you can bring the vulnerability issues to your smart contract using vulnerable dependencies. I have small point here regarding the dependencies. Always check the Rust docs of the imported functions within your smart contracts. Sometimes if the Rust docs are obviously written correctly, the author will include also the, let's say, security risk or the checks that are not performed within the functions, so you can keep this in mind and implement the checks within your Solana program. And you are actually aware that the function you are using, the external function you are using from dependency, has kind of security issues, so you can prevent these. That was all from the code quality. There is bigger portion of points that can be implemented during the code quality. As you could see, the code quality part is actually the biggest in the iceberg. But yeah, my suggestions are that keep up to date with the most common security issues, not only the best practices. And keep learning, and do not be biased towards that you are writing completely secure smart contracts or applications. Now we can move to the testing. In this slide, I would like to not talk about the common testing practices of writing tests, integration tests in TypeScript, but about the more important things that I think are most of the time forgotten, but you can implement them in the workflow of creating the applications, even Web2 or Web3. So the first point is about the security by transparency. Encourage open audits, code reviews, bug bounties. Currently, you can see we have the task for the fuzzing, and we encourage students to actually fuzz the open source Solana programs. So we want to increase the overall security of the Solana programs that are deployed on the mainnet. Instead of using black box fuzzing, we want you to actually use the open source code and fuzz the Solana programs. There are also multiple independent security researchers that would like to break your programs. There are even security researchers, they play the capture the flags, so they are actually enjoying even for free to breaking things. Maybe you know the Trezor brand of the hardware wallets. They have story, because they are open sourced. They have story that on the GitHub someone was reporting really often I don't want to say that the treasurer is vulnerable, but someone was reporting issues on their GitHub, and the someone was doing it for the bug bounties and for the fun. After some time, they discovered it was some 15 years old guy, I think. So most of the time, there are a lot of people that, want to break things for money, but they also want to have fun and want to hack things even for free. So security by transparency is the first point you can actually implement. There is, I think it is called code for Arena. You can list the project here, and you can have the independent audit here. Again, think like an attacker. Best testing approach is when you try to destroy your smart contract. So on the other hand, of course, test correctness of the program, but test also the vulnerable parts. Try to break the program, try to input incorrect, invalid or unexpected inputs to your smart contracts. Try to sit down and think, what is actually the vulnerable part here? Isn't the vulnerable part exploitable? If I'm an attacker, what would I do? And these are all the questions, some of the questions you should ask during writing the tests, not only to ask if this integration test is correct this way and if this integration test catch this anchor error. The next point is about the blue teaming. Blue teaming means, or the blue team is responsible for monitoring, detecting and responding to attacks. This is again really important part. Test how fast or how good can you, or if you can sufficiently monitor the behavior of your protocol. Test how fast can you detect the attack. Can you even detect the attack, or you will learn from Twitter that your protocol was hacked? Then test how fast can you react to the attack. How fast can your team respond? How fast can you fix the bug? How fast can you communicate to the community or to the users that the smart contract was hacked and what was the problem? These are probably the response and the monitoring and the detection are the most important three parts here. But you need to also be responsible and learn or test how you can communicate the issues. What should the users do when the smart contract actually gets hacked? So again, do not test only the integration tests and write fast tests, but this is also an important part during the workflow to test the responses to the attacks. Next point is about the security regression testing. This actually happens often. Retesting is really important because not always, but most of the time, let's say Auditor finds an issue in the smart contract, the issue gets reported, and the developers think that they fix the issue and everything is resolved. But they do not test if the issue was fixed correctly. And the first thing that can happen is the issue was fixed incorrectly. And the second thing that can happen is that the issue was partially or even completely fixed, but they bring different issue while fixing the first one. So always make sure when you resolve the issues, always make sure that the issues are resolved correctly and you did not bring different issue to your smart contract with the fixing the previous one. The last point here, social engineering testing. In this case, I'm not trying to say to be overly controlling or harsh with the employees of your company or members of your team, but if you have some members or employees that are not experienced within the information technology sector or within the cybersecurity sector, you as a leader need to educate them that clicking on the random links within emails or taking free USBs on the reception or somewhere in the park is a big security issue. So this is your responsibility to teach the members of your team, to teach the employees of your company that they should avoid this behavior. That was all from the testing perspective. I was not talking about how to write the best integration tests, because you already know how to write the best integration tests. You always need to test extensively. So that's all from the testing part of the iceberg. And now I would like to move to the more advanced testing, but in this case we are focusing on fuzzing. So I will talk about the fuzzing. From the fuzzing perspective, there are few points that I would like to touch. We already had 2 lessons on fuzzing. The part 1 was mostly introduction into fuzzing. I was talking about what fuzzing is, what are the importances of fuzzing, what are the results we achieved. And the second part was more about the features or advanced methods or approaches that you can use while you are writing the fuzz tests. In this lesson, or in these slides, in this slide, I would like to just briefly touch what the fuzzing is. So for those who don't know, who are watching this lesson but did not watch the previous ones, the fuzzing is testing technique that involves inputting a large amounts of random data into the program. Random data in this case means valid, invalid, or even unexpected data. So I like to refer to this technique as integration tests, but on steroids, where you specify or maybe guide the fuzzer about what should be the inputs, what should be the accounts that the instructions expect, the instructions of your smart contract, and the rest is on the fuzzer. So the fuzzing engine actually generates random inputs, and these random inputs are on the input of instructions of your smart contract. So what's the connection to the integration tests? The connection is such that within integration test you specify by hand the inputs, and these inputs are in each running of the integration tests the same. However, during the fuzzing you can run the fuzzer for, let's say, 1000 of iterations, and in each iteration you can specify the instructions you want the fuzzer to execute, and each iteration consists of random input data or random accounts. So these are like multiple iterations of integration tests. That's why I refer to this as integration tests on steroids. And there are multiple approaches to the fuzzing, multiple terms in the fuzzing space, let's say, that can describe how the fuzzing is done. I would like to talk only about a few terms that I have here, so this should provide more clarification to the fuzzing, so you can understand more about how can the fuzzing, for example, work. So firstly, I have the black box fuzzing. So actually, the black box fuzzing means that the fuzzing is without any knowledge of the system. This would mean that the fuzzer does not know what the system inputs are. In this case, for example, for the Solana program, the fuzzer, or from the other hand, the trident knows what is the interface of your Solana program, what are the inputs in your Solana program, so if the inputs are integers, vectors, what are the accounts, so the fuzzer can generate accordingly the random data from the range of the integers you have on the input. On the other hand, the black box fuzzer does not have the knowledge, so the data is completely random. The next is white box, where the knowledge is of the whole internal workings, so the fuzzer can behave accordingly based on the internal workings of the smart contract. And the last part is something in the middle, which is gray box fuzzing, that is with partial knowledge of the system. I have specified the interface here. So the fuzzer, actually, the trident, knows what is the interface to your Solana program, so the fuzzer can generate accordingly the input arguments. So let's say the fuzzer knows that your initialize instruction expects vector that is long or array that is long 32 bytes, or it expects public key. So the fuzzer knows this and can generate the public key accordingly. There is also a term that is coverage guided. So in this case, the underlying fuzzing engine can actually monitor the code coverage as it runs. Simplified version of this sentence is that the fuzzer checks how much code it successfully visited in your Solana program. So let's say it generated some random inputs and the execution failed at the start of the Solana program because it was not possible to pass some instruction checks that you specified. However, for different random inputs, the fuzzer could go deeper into the Solana program and failed after the, let's say, the third check in your instruction. That means it visited more code. So it can focus more on these inputs and modify other inputs. So it can continue deeper and deeper in your Solana program. Trident is coverage guided gray box. So it knows what is the interface to your Solana program, and it is coverage guided. This coverage guidance can be turned off or turned on. So the trident can decide based on the coverage what should be the next inputs or the inputs in the next iteration. We went through the part 1 and part 2 of writing fuzz tests, so I think we have this covered. But what is important is actually the crash analysis. So when the fuzzer finds crash, the crash analysis is actually the process of analyzing the crashes or failures caused by the fuzz test. In this case, we were talking about this in the, or I showed you in the part 1 and also part 2, how to investigate the crashes. So this is important step within the fuzzing of your Solana programs. The next important point can be automated fuzzing. So it is worth noting that it might be helpful to write GitHub pipelines, for example, and every time you create pull request to, let's say, some of your branches, the pipeline will trigger and the pipeline will run the trident for some particular amount of iterations. And you can see the results in the pipeline. So you have automated fuzzing. If the pipeline finds the crash, you know that you have issues in your smart contract or in your application, and you can investigate it deeper. So this was briefly from the fuzzing perspective, and now we can continue to the last part, which is the audits. I will cover this from the two perspectives, from the perspective of a developer, and also the second part is going to be from the perspective of auditor. Let's start from the perspective of a developer. So we can see from the pyramid on the right, the first part was the biggest one, that was the code quality. The middle part was regarding the testing, and the tip of the pyramid was about the fuzzing. So you successfully went through all of these steps, all of these parts of the pyramid. You think you made great work in each of the part, and now you would like to prepare for the audit, or you would like to make the best efforts for the auditors to audit your smart contract the best. So what is important? The first thing important is the structure. This is important from a lot of points, not only from the point of the audit, but if you make the code well structured, firstly, it can help you better navigate in your application. You may even better understand the smart contract. The second part is from the auditor's perspective, but when the structure is clear and the code is well structured, we can faster understand the smart contract. We can also better navigate in the smart contract. Maybe when you have the good structure, you don't end in situations where you have some logic specified actually 2 times. The next point can be, it can help your team members to faster and better understand the smart contract. So if the smart contract is actually well structured, the new team members can better understand the logic and can be faster included in the workflow, in the development process. I remember from my studies at the university, in the first year of the university, I wrote some, not smart contract, but I wrote some C code. And after some time, I wanted to get back to the C code, and the C code was C, I mean the programming language. The code was complete mess, and I wasn't able to navigate in the code because the code was not well structured. Everything was basically in one file, and if the file has 1000 of lines, then it is really hard to navigate in such source code. So this can be also the next point. If the structure is alright, then let's say you develop the smart contract and you do not want to do additional changes right away, but you want to see the feedback. You want to see how the application behaves in the real life scenarios. So you take, let's say, break for half a year, so you can see the outcomes of such application. And after you come back after the half of the year, after the 6 months, then if the code is well structured, you will definitely faster understand what you developed before the 6 months. So that's from the structure. The second point is documentation. Document design and code to help us, our auditors, better understand the design, but this can also be extended to the first part when you want to, after some time, faster and better understand what was the design before the 6 months. You want to also faster the process of understanding of your colleagues and team members. It is also important to document this because if the application is robust or the protocol is robust, it can contain also a lot of system components which are important. Even the system components can be off-chain. It does not need the system components not necessarily need to be the smart contracts, but for us auditors, all of the components, even off-chain, can be or are really important because we need to understand the architecture of the protocol or the application as a whole, not just the smart contract. So mention everything you think is important. You do not need to write detailed description of all of the components, of all of the instructions, of all of the external dependencies of your smart contracts, but at least mention that what is this, why is this component important, maybe visualize the layout, the architecture of the protocol. I was talking about the Obsidian. You can create nice graph in the Obsidian and visualize the whole architecture of the protocol. Do not forget to talk about the environment. Let's say you have some specific environment that is required to run your smart contract or run your application. It is important, again, from a few points. Firstly, some other colleagues or team members want to replicate this environment, want to test the application. So for them, it is important to know how to set up the environment, how to run the tests in the environment, and so on. For us auditors, it can be the same, but it is also important to mention the environment because environments can behave differently. So maybe in your environment, the application can be secure and everything goes smooth. But there might be some different environment where attackers are available or allowed, that's a better word, allowed to create security issues with your applications, and that can result in the bugs in your application. So mention everything important regarding the environment. And last point that you can make here, which is also important, is the uniform scope. Do not change the scope of the audit during the audit. If you would like to write better tests, I think this is still okay. If you want to change one line in the smart contract, it can still be okay. But please do not add some additional different robust logic to the smart contract, which can disrupt actually the auditing process. That's from the perspective of an audit, that's the audit from a perspective as a developer. Now we can continue to the perspective as an auditor. So you need to understand everything, that's it. That was a joke, obviously. I have more points specified here. The first point is cliché, but you need to learn. And I always have questions or got questions that are where people ask me, how can I start auditing? What should be the steps to learn how to audit smart contract? How to actually develop smart contracts? And my recommendations are always learn. And I cannot give you like the exact path and exact steps, what to learn first, what to learn second, what to learn third, and so on until you are auditor or penetration tester. Because everyone has its own path. What are always my recommendations is to start shallow. So start with basic principles. In this case, if you want to be Solana auditor or some different chain that, let's say, uses Rust, learn Rust. Learn Rust as deep as possible. Then go to the anchor, but not only the constraints that the anchor has, not only the accounts that the anchor supports, but learn also the logic as I was showing or presenting in the lesson 1. Understand what is behind these constraints, these accounts. I told you that you can use anchor expand to actually expand the macros and check how the expanded code looks like. And understand this expanded structure, not the macros and so on. This is like the tip of the iceberg, that you know in which case what account to use, or in which case what constraint to use. So learn and understand the anchor framework. The next point is learn common vulnerability vectors. From the anchor perspective, there are multiple best practices or common attack vectors. We are going to talk about this in the next lesson. You should avoid, or you should know, in order to create secure smart contracts. But there might be interesting points also from the vanilla Solana perspective. So in order to increase your knowledge and to increase the understandings of the Solana security, learn also the common attack vectors from the vanilla Solana perspective. Then learn, for example, the architecture of Solana. There is really good point of learning how to navigate in the source code of Solana. You can the Solana source code is actually open source. You can see it on the GitHub. And I would say basically daily I open this GitHub of Solana, and I almost daily check how any kind of stuff is implemented. And yeah, you may know that Solana has documentation, which is ok, but the source code is always a better source of truth. So if you are not sure about anything, check the source code. So yeah, learn the overall Solana architecture. For example, the Helios has a great article about the overall Solana architecture. So read the architecture, read the blog post or the PDF, and ask questions. Currently, we have a lot of available options where to get all answers. You can go to social networks such as Twitter. You can ask people these questions. You can type it into the AI, and let's say ChatGPT will give you answers. I'm not saying that ChatGPT is always right, but you can went through the nice conversation with the AI regarding the architecture, and it may help you to clarify things. Then you can go even deeper. You can learn cybersecurity principles. Even the principles, not cybersecurity, but cryptography. Not only the cryptography principles from blockchain perspective, but there are plenty of from the Web 2 perspective. You can learn the math. You can learn the elliptic curves. You can learn the ciphers, the block ciphers. IS, you can learn the DES. You can learn the possible attacks on these block ciphers. They are used basically daily, so this will actually only increase your knowledge and experience. Really great word for the last few months, let's say maybe maybe year and a half, is zero knowledge. Learn how actually the zero knowledge works. I know that the zero knowledge actually started, I think it was like in the 80s or 70s. There were very simple. There were very simple algorithms that provided actually the zero knowledge, or the basic idea of zero knowledge, where you provide proof without revealing actually the contents of the secret you know. And all of this stuff has its own possible attacks. For example, the padding attacks, oracle padding attacks. For the elliptic curves, there are possible signature malleabilities. There is big portion of security is about the side channel attacks. And I'm not saying that you should be professional in every of this part, but at least get familiar with this. And when you learn all of this stuff, you are getting better and better, and you are approaching the professional state of the security. And the last point is you always learn and always monitor. So apart from learning from the history or from the past, you should always learn what are the most common security issues in the present. So monitor, for example, the OWASP. You may know some different kind of source that provides such information. So monitor these informations. And what is really important to mention here is also the approach to the monitoring. It is not important to just open the web and go through the OWASP 10 in 10 minutes and then forget. Important is to read the stuff, understand the stuff, and to think about the stuff. Maybe ask questions. How can you resolve these issues if you have them in your smart contracts, or what are the results of the issues, and so on. So this is also really important. The learning is actually the biggest part, how to become an auditor. So that's the question I've got asked a lot, so that's why I included it here. One last thing that I forget to mention is it takes time. It is not like the one night process that in the evening you start learning security and in the morning you are security professional. It takes time. It even can take months, even years, to become familiar with all of the terms. Okay, so what are the next steps when you are actually auditing some application or a protocol? Firstly, it starts with understanding the system. It is really important for the auditor to understand the system as a whole. Not only the smart contract, but also the off-chain parts, the external parts, the dependencies, and so on. The second point is about monitoring progress. To be consistent, you should monitor your progress and not jump from one part to another part. You start with understanding the system as a whole, and you go deeper and deeper and deeper with the manual review. As an auditor, you should always review the architecture, not only the smart contract, not only the formal check of the smart contract, if the constraints are correct or not. The architecture as a whole is important. There are, again, important questions that the auditor should ask. How much is the system fair to the users? How much is the system actually centralized? We have the decentralized blockchain, but the system still can be centralized and operated by one authority. How much control does a particular authority have? That's basically the same scenario. Next question, at some point in time, are the users' funds at risk, for example? And these are all of the questions that can be answered when you understand the architecture as a whole, not just only the few lines of code in the smart contract. And it is also important to understand the outer components. So again, apart from the smart contract, you need to understand, let's say, the external dependencies. I was talking about the Rust docs and how you should always check the Rust docs for the external for the external functions. This is important because you can use external functions for, and I'm not saying that the functions are always vulnerable, but let's say you want to include some functions even from the Solana SDK, and the function does not perform the required checks for the function to be completely secure in your scenario. So you should be aware of this as a developer in this case, and you should perform the checks on your side. But if you do not understand the outer components, you do not know that there are these possibilities. So it starts from dependencies to protocol parts. We always need to understand not even the smart contract, but also the off-chain protocol parts, or even, as I was talking about, the employees in the company. This is really, again, important part because your system can be secure, but it can be vulnerable from the unexperienced team members, for example. So now about the manual review. So the manual review of the smart contract, okay, I would say from auditor to auditor, this can be different, but it always, I would say, starts with shallow manual review. So again, you go through the code base, which should be well structured, and you go deeper to particular lines, to particular functions, parameters, structure fields, even array contents. Let's say your smart contract expects byte array on its input, and you need to investigate all of the possibilities that can be within each index of the array. And in parallel, as I was talking about the learning, and in parallel, you learned a lot of stuff. So you monitor everything and scan everything you see in the source code, and in parallel, you scan it with the knowledge and the experience. So you can discover the issues, the bugs, the vulnerabilities. Then, when you discover something, you need to think about the impact and the likelihood. It is not like you discovered an issue, it is automatically critical. No, because the issues can be various from the smart contract to smart contract. In some smart contract, let's say the reinitialization attack, or I was talking about the signature malleability. In some smart contract, it can be critical because it can create double spend. In some different smart contract, the signature malleability actually does not create any security issues, and only the developers should know that this is the case of their smart contract, but it does not create critical issue. So you should be aware that there is something like impact and the likelihood of the issues. Then what is the patch management? Examine if the system is kept up to date, for example. How can the team address the vulnerabilities you send them regarding the manual review or regarding the architecture, regarding the off-chain components? So these are all important steps in the great auditing. But there are also steps to keep in mind. What is also important to check is the development and deployment practices. So, do all changes go through a peer review? Are the changes well tested? Or even, are there any automated testing techniques? As I was talking about, for example, the fuzzing or the GitHub pipelines. Are there multiple people that review, for example, the pull request, or is it one-man show where one developer creates the pull request and also reviews the same pull request? Assess the risk management. Are the previously found issues already resolved? Are the previously found issues correctly resolved? Maybe did not the fix bring another security concern? I was talking about this. Make sure always that the fixes you made to the security vulnerabilities or security issues, the fixes should be correct. Firstly, the fix should actually fix the issue, and secondly, you shouldn't you shouldn't bring another security concern to your smart contract. What is then really important? Communicate the findings. Communicate the findings correctly. The critical and high security issues communicate as soon as possible. If the protocol is already online during the audit, this can happen because this can be the second, third, fifth audit of the already deployed protocol. Make responsible actions to prevent any leaks. Do not communicate the security issues with others. Maybe share it with your team members, but do not write on Twitter that you find a security risk in this protocol, in this smart contract, and the security risk can result in this much assets stolen. Be responsible and communicate the issues only with the team or protocol members. Again, I was talking about the privileges and some role-based access control and the least privileges. It can be applied also here. Do not write the security issues to the some public email of the company where all of the company members have access to, but write the security risk, the security risk you found, to one team member, one core developer, or one team lead in the company. So different team members cannot misuse the security risks. And what is also important, review the incident response. As I was talking about, you should test the blue team. So in this case, we need to know as auditors how the team actually monitors the protocol, how the team can actually detect any security issues. Can they detect it, let's say, in seconds, or are they going to know that their protocol was hacked from Twitter? How fast they can react? Can they react like immediately, or maybe some after a week the fix will be released? So these are all of the important points that you should keep in mind during the audit as an auditor, not as a developer. So to recap, we went through all of the parts of this iceberg, or all of the pillars of security, starting from the code quality. That's the developer's responsibility. Testing is the same developer's responsibility, or maybe team members regarding the testing the team members or educating the team members for the best security practices. Then you should apply some advanced testing methods. In this case, we were talking about the fuzzing, and the tip of the iceberg is dedicated to was dedicated to the audits. I have one sentence here that is always true, and the security of a system is as strong as the most vulnerable parts in the system. So this can go from the source code to even the employees, as I was talking about. That was all from the best security practices in this lesson. One thing that I forgot to mention in the introduction is that the CTF is not mandatory, so no worries if you do not pass the CTF, no problem, nothing actually happens. And yeah, I hope you enjoyed the lesson. As I said, check also the second lesson about common attack vectors. I think you definitely learn a lot of new stuff from the security perspective of Solana programs. And yeah, this is everything. See you at the next lesson. Bye.